In this video, I'm going to go through the other sheet that I've given you, Chapter 6, Radians, Homework 1. I'm just going to go through the answers. Area of the sector is 24, angle containing the sector is 60, find the radius of the sector. Well, we can either work in degrees or we can work in radians. It's actually given us a hint here saying draw a diagram and remember to work in radians. Well, that means we have a sector. 60 degrees is pi over 3 radians. And we know the area is 24. So area is equal to a half r squared theta, which is a half times r squared times pi over 3, and that equals 24. That ends up being, oh, let's just do it this way. So if I divide by a half, that's 48. I just need to do 48 divided by pi over 3. And that comes out to be 48 times 3, 144 over pi. So r squared is 144 over pi. How do I get r? Well, I square root it. The square root of 144 is 12. Remember, there is no need for us to work out the negative version because it's the radius, so it must be positive. Right, next one. Sector contains an angle of pi over 5 radians and the area is 30. So now we've got the angle. We're going to use the same formula. So A is equal to a half r squared theta, which is 30 is equal to a half times r squared times pi over 5. Same thing again. Double this is 60. Times by 5 is 300. Divide by pi gives me 300 over pi is equal to r squared. So r must be the square root of 300 over pi. I'm doing these as exact answers. Obviously, you can check with your calculator that you get the same answer if you've done it to 3 significant figures. A sector of area 12 has a radius of 4.2. We've now got to find the angle. So 12 is equal to a half times 4.2 squared times theta. Slightly easier this one. So 12 times 2 divided by 4.2 squared comes out to be 200 over 147. Now that comes out to be 1.36 radians. Look what they've asked me to do. They've asked me to find the size of the angle in degrees. Now, I'm going to do this a ratio way. You might think I'm a little odd, but this is how I do it. I know that pi is equal to 180 degrees. This is my radians. These are my degrees. So I want to get down to 1.36. I'm going to divide by pi and times by 1.36. So I'm going to divide by pi and times by 1.36. Now this number is in my calculator, so I'm going to use the answer button on my calculator to get the most accurate result. So 180 divided by pi times by the answer that I had previously tells me that theta must be 77.95 degrees, or if you prefer, 78 degrees. D. We now need to find the perimeter of the sector. So let's quickly draw ourselves a diagram here. We know the radius, we don't know theta, but we do know the area. So what I'm going to do is first find the radius. Then, to find the perimeter, I'm going to need the radius, and the arc length. Because remember, perimeter is right the way around the side. So let's start by finding out what. Oh, I don't mean my radius. I've got my radius. I'm going to start by finding theta. So, area is equal to half times r squared times theta. 45 equals a half times 13.4 squared times theta. Leaves me with theta equal to 45 times 2 divided by 13.4 squared. Gives me that theta is equal to 0.50 radians. What is the length of an arc? Well, the length of an arc is r theta. So it's 0.5 radians times 13.4. Obviously, once again, I can use the answer button on my calculator because I've still got the previous answer in there to get my most accurate result. Well, that tells me 6.72. So what's the perimeter? Well, the perimeter is equal to 6.72 plus 2 lots of 13.4. These two sides here. Remember I said it's all the way around. And that comes out to be 33.5 centimeters to 3 significant figures. Right, moving on to the back now. E. The arc length of a sector is 8.7 and its radius is 9.2. We need to find the area. So we're going to go backwards on this one. Arc length, S equals r theta. The radius is 9.2, so 8.7 equals 9.2 times theta. So theta must be 8.7 divided by 9.2, which is 0.945. Actually 946, if I'm going to round it. Now I need to find the area. Area equals a half times r squared times theta. So that's a half times 9.2 squared times my theta. Once again, please use the answer button on your calculator to get the most accurate result. So 0.5 times 9.2 squared times answer gives me to 3, it comes out as nice 4 significant figures. So I'm going to leave it as 4.02 centimeters squared. Right, F. This is the pesky segment. All right. So this is called a minor segment because it's just a little section. And a segment, as you can well see, is going to be the difference between the sector and a triangle. We were playing around a little bit with this earlier when we were looking at small angle approximations. Right, so how am I going to find the area of the minor segment? Well, I'm going to start by finding the area of the whole sector. So the area of the sector, that's usually called O, OAB, is equal to a half times 5 squared times, oops, I'm in the wrong one here. I need to change this. So pi is equal to 180 degrees. I need to get to 72 degrees. I'm going to divide by 180 times by 72. So divide by 180 times by 72. So pi divided by 180 times by 72 gives me an answer of 2/5 pi. That was rather nice. So that is my radian measure. Right, put that in. And I get the answer of 5 pi. So that's the area of the whole sector. Now I'm going to find the area of the triangle OAB. Well, that is, if you remember rightly, a half AB sine C. So it's a half times 5 times 5 times sine of 72. Now in this particular case you've got two choices. You can either go and put your calculator into degree mode and use 72, but remember if you're in radian mode then you need to put the radians in. Now my calculator is in radian mode, so I'm going to put it into radians. So I get 0.5 times 25 times sine of 2/5 times pi. Okay, that times pi, I'm just going to show you my calculator, is actually in brackets because it's part of the angle. And that comes out to be 11.88, which I can summarize as 11.9 centimeters squared. So what is the area of the minor segment? Well, it'd be the area of the whole sector minus the triangle. So the answer is the area of the segment is equal to 5 pi minus the answer I've just got. Remember to use the answer button on your calculator. So 5 pi minus my answer gives me 3.82 centimeters squared. Bit of a tricky one, that one. Right, G. The area of a segment is 20 and the angle subtended by the chord forming the segment is 1.3. What's the radius? Aha, this is the area of the segment. And we need to find the radius of the circle. Now, there is a fancy formula. I'm not going to use a fancy formula. I'm going to show you how to do it without the formula. Because another formula is usually a bit of a pain in the backside to learn just another formula. So let's just do the ones we've done so far. So the area of a segment, well, the area of a segment is equal to the area of the sector minus the area of the triangle. Now I'm going to call the radius r. Well, the area of a sector is a half r squared times 1.3 r squared theta minus a half times my radius times sine of 1.3. Are you following so far? So there's my triangle, and I know that is 20. So let's just solve this. Well, I could simplify this a little, and I could work out that a half times 1.3 is 0.65. So 0.65 r squared minus sine of 1.3. Once again, my calculator is in radian mode. Times by 0.5 is 0.4817. Well, these are both r squareds, so I can subtract them. So I'm going to do 0.65 minus answer button is very powerful, and gives me 0.16822. 0.16822, I forgot the one, 22 r squared is equal to 20. So I do 20 divided by the answer, I then square root because I need just the r, and I get my r to be 10.9. I hope that makes sense to you. Any questions, just ask me when we link up for our little meeting.